Well, hello, ECON 120. I hope everyone's doing well this week. To prepare you for your quiz, I'm going to go through some concepts of Chapter 11, and I will be focusing on the production function and cost functions. So let's jump right into it. And here in this first exercise, you're given some information about Nisha's production function, and we need to answer the following questions. Here, Nisha is a surgeon who maintains an avid interest in economics. So let's see what's happening. Here, how you read the table is the quality of labor, which is hours in surgery, the quantity of capital, in this case, it's number of operating rooms, and it'll give you how many surgeries you're able to produce. So given that you have 30 hours of surgery plus 0 operating rooms, you'll get 0 surgeries produced. And you can read the, this line as 30 hours in surgery and 1 operating room, you're able to produce 15 surgeries. So given this information, let's see what we're asked to do. The first thing we're asked to do is find the MPC. What is MPC? Well, it is the marginal production of capital. And what it's saying is, how does production, the number of surgeries you're able to produce, change as capital changes? And so here, it's the change in quantity over the change in capital. So what is the change in quantity? Well, that's number of surgeries per operating room. So I'll call it OR. So it's similar to finding marginal benefit and marginal costs, as we did last week. So here, let's start. Well, there's no prior information, and so we're going to put a little dash line here because there really is no marginal production of capital. But now if you start at 1 operating room, what is the change between 0 and 1? It's 1. And the change between 0 to 15 is 15. And so here we get 15. But it's 15 surgeries per operating room. Now let's move on. What happens when we get 2 operating rooms? Well, the change between 2 to 1 is 1. The change from 15 to 25 is 10. And so now it's 10 surgeries per operating room. Conveniently, this will all be 1. And to go from 25 to 32 is 7. And from 32 to 35 is 3. So 7 and 3. And the same units apply. So we just found this first thing. Next, let's sketch the production function and the MPC. Before I go on, what do you think the marginal production of labor is? So imagine I took this problem. Instead of finding MPC, we found MPL. Well, to go from 30 to 30 is 0, 0, 0, and 0. And so there is no, so instead of finding capital, we wanted labor. There would be none because labor's not changing. And here, labor is constant. How do I know it's constant? Well, the 30 never changes. When you have one of your inputs of the production function constant, you're talking about the short run production function because you have a fixed input. Given this, we can sketch our production function, which I'll do in blue. So how about we label this 1, 2, 3, 4, and 5. Here it only goes up to 4, but so when you have, this is capital, or number of operating rooms, and this is number of surgeries. Sorry, my writing's a little sloppy. And it makes sense that as you increase the number of operating rooms, that the number of surgeries should increase, right? Sorry, I'm just trying to draw this to scale. And we get this nice looking graph. So this is our production function. So I'll call it PF. Don't get this confused with the PPF. This is simply PF for production function. Now, when I draw the MPC, notice if I drew little tangent lines, the tangent lines are getting flatter and flatter. And so what that's saying is that as capital changes, the production changes slower. And so it should look something like this. If you're not sure how I got this curve, another thing you can do is just look at these numbers here. And the red's going to represent our MPC. If you're taking another econ class, you might be used to this being called the MPK. So in economics, we often use K for capital instead of C because we like to use C for cost or consumption. So in case you're used to seeing it one way, just to clarify what's happening. Now, let's look at this red curve. Well, the MPC simply says that for every additional unit of operating rooms, you're going to have positive returns, but it's going to decrease. And so we have diminishing return to scales from this production curve. So it says that as you increase the number of operating rooms, you're going to not be as productive as you were that very first unit. So given the information in the table, is Nisha's production function short run or long run? Well, remember, we have labor is fixed. And whenever you have an input that's fixed, that implies short run. And so the answer here must be A, short run production function. The fixed input of Nisha's production function, well, we already discussed its labor. That means the variable input is capital. So the variable input in this production function is capital. And what we want to know is Nisha's marginal production of capital from building a third operating room. Well, luckily for us, I made us go through the MPCs for each additional unit. So here's adding a third room, and we get 7 surgeries per operating room. So let's see if that's one of our answers. And it is. So if you're not sure how to find it, you just take the change in output over the change in capital, or more explicitly, Q2 minus Q1 over C2 minus C1. Nisha's production function exhibits diminishing returns to capital because, is it A, output increases at a diminishing rate as additional units of capital are built? Is it Nisha cannot perform competently with more than one operating room? Capital in the form of operating rooms is highly expensive. Output does not increase at a constant rate as an additional units of capital are built. So let's think about it. Well, we don't know anything about competency. And really, if you have more operating rooms, you should be able to produce more surgeries. So B doesn't seem like a great answer. Probably building operating rooms is expensive, but that's not even mentioned in the problem. So C shouldn't be an answer either. So let's think about it. Is it A, output increases at a diminishing rate as additional units of capital are built, or output does not increase at a constant rate as additional units of output are built? Well, it doesn't increase at a constant rate, but it is increasing, right? It's increasing by some rate, but it's getting smaller and smaller. And so here, I'm going to argue that the answer is A. Okay? That output increases at a diminishing rate as additional units of capital are built.